All right, today we're talking about a totally new kind of artificial intelligence. I want you to think about an AI that doesn't just crunch numbers in rigid, blocky steps, but one that actually flows, almost like water. Let's dive into liquid neural networks.
That's a pretty bold claim, right? When Liquid AI dropped this announcement, they weren't just saying, hey, we made something cool. No, they were framing this as a huge leap forward, not just for them, but for the entire field of AI.
So the whole idea here is an AI that's just incredibly efficient. We're not talking about those giant power-guzzling data centers in the cloud. Nope. This stuff is designed to run right here, locally, on the devices that you and I use every single day.
And that's the big question, isn't it? How on earth does it actually work? And why is everyone getting so excited about it? Well, that's exactly what we're going to unpack. We'll get into the science, the performance numbers, and what this could all mean for the future.
Okay, first up, let's really dig into what makes this new model so different from the kind of AI we're all used to hearing about.
So, for a long time now, the big player in AI has been something called the transformer architecture. I mean, it's super powerful, don't get me wrong, but it works by processing data in these rigid fixed steps. It can be slow, and it takes a ton of computing power. You can almost think of it like solid block, strong, but totally inflexible. But Liquid AI's models, they're coming at it from a completely different angle. They've tossed out that rigid structure. Instead, their whole thing is built around this idea of continuous adaptive processing. It's a whole new ballgame.
And what's the payoff for this new approach? Get this. Their models are showing a 200% higher throughput on a regular old CPU. We're talking twice as fast as the top competitors, running on the kind of hardware you probably have in your computer right now. So you've got to be wondering, where did an idea this different even come from? Well, it didn't just come from a bunch of computer scientists in a lab. It actually came from biology. Yeah, from studying the nervous systems of tiny little organisms.
The core idea is something called a liquid time constant network, or LTC for short. Basically, researchers looked at how simple neurons, in small creatures, handle a constant stream of information from the world around them. They're always adapting, always changing their response in real time. And that's what they built the model on.
This really breaks it down perfectly. Think about it. Traditional AI is like a solid. It's stable, sure, but it's rigid. Liquid AI, well, it's exactly what it sounds like. It's liquid. It processes data in this continuous flow, which makes it way more flexible and efficient. But, and this is key, it's still stable and predictable. Okay, now this is super cool. This visual shows you exactly what that flexibility looks like. On the left, you've got a really simple input signal, right? A basic circle. But look at the right. That's how a liquid network sees that same signal. That incredibly complex, tangled shape. That's not just a mess. That's what the researchers call superior expressivity. It means the network is building this incredibly rich, detailed internal map of the data. It's seeing connections and context that a more rigid model would just completely fly over. So this whole nature-inspired thing was amazing, super expressive, but there was one big problem. The early versions were actually pretty slow, so let's look at how they cracked that nut. Okay, so the original models had to solve this really complex math problem. It's called an ordinary differential equation, or ODE, for every single step. And that process was a huge bottleneck. It just slowed everything way, way down. And the breakthrough they had was just pure mathematical genius. Instead of making the AI do all this hard work, solving the equation over and over again, they found a shortcut. It's called a closed-form solution. Think of it like this. Instead of following a long recipe with tons of steps, you just have a magic formula that gives you the final dish instantly. And that one idea, boom, it unlocked insane speed gains. And this is what led to the next big evolution, closed-form continuous time networks, or CFCs. They've got all that same expressive power of the original models, but now they are just wildly faster, fast enough to actually be practical in the real world. Okay, so we've got a model that's fast and smart, but how does it really stack up when you throw some tough, messy, real-world problems at it? So they put it to the test. We're talking about things like predicting patient outcomes from medical data, running physics simulations, and even autonomous driving. Basically, any task where the data is messy, noisy, and totally unpredictable. And the results? Honestly, they're kind of staggering. On one medical data set, the CFC models were, wait for it,
160 times faster to train than the old models. 160? That is a massive, massive leap in efficiency.
And it isn't just about being fast. In a really complex physics simulation, these CFC models actually beat the powerful transformer models by 18%. So they're not just faster, they can be more accurate too. Now, this is absolutely huge for things we care about in the real world. I mean, think about self-driving cars. When they tested this tech in a car, the model was amazing at focusing on what's important, the road, even when the camera data was noisy or partly blocked. That kind of reliability is everything when you're building AI you can trust.
So when you put it all together, speed, efficiency, reliability, what does that actually mean for us? Well, it means we can finally start moving AI out of those giant data centers and, right into our own hands. This is what people are talking about when they say edge AI. It means that AI runs right on your device, so you get instant responses, no lag. It means your AI works even when you don't have internet. And this is a big one, your data stays with you on your device, which is a huge win for privacy. It basically turns every device into an AI device. Really, the end game here is to make powerful AI accessible to everyone. Just imagine your phone, your laptop, your car, all of them having the power to think, to reason, to create stuff on their own without ever needing to phone home to a massive server in the cloud. This move from a centralized AI in the cloud to a decentralized AI everywhere, it could completely change how we interact with technology. And it really leaves us with a pretty wild question to think about. What actually happens when every single device can think for itself?